Die demonstration by going into the die design wizard. Here I'm just picking the geometry, the part that I'm going to work with, looking at the different names of the project that will go on the folder that stores all the part files in. Here you can see the geometry on my screen. This is the part. It's a pretty straightforward cover. It's got a big flange going around it, and then other areas that need to be unfolded. To get more information about the part, I'll jump over into the measurement tool. This quickly gives me my overall X, Y, and Z size. It'll give me density. It'll give me mass, basically the cubic volumes, all those sorts of things. Wanting to get a little further understanding of the part, let's look at the angles of those flanges. The dialog box shows that the colors are set so that purple is straight up and down vertical. Anything curved back under itself would appear in red. The tooltip shows me exactly what the angle is at any given point. I'm also very concerned with the radiuses. I want to make sure that they're generous enough to make good forming conditions. I might be concerned with what the smallest radius is, and you can see it's just a matter of setting color ranges to what we prefer to see. And that tooltip again, you see everything as far as what each radius is. Lastly, we want to see if there's a uniform wall thickness. So here we'll see if there's anything discolored. It would be either thicker or thinner. And again, a color range can be established to what we desire. With the tooltip showing us exactly what each area looks like. There's a nice dynamic sectioning tool also to show us at any given point something that maybe we have concerns with. We see an area that's thinner. Is it being coined? Is it just drawn incorrectly? We get the answers to those questions very quickly. Well, with that, we've got a pretty good understanding of what the part looks like and what it's going to do. So we understand some of the requirements now that we need to deal with to unfold it, form it in a strip. So let's begin working with the part. Here I'm simply giving it the next station a name. The idea here is if I wanted to, I could set my distance, not necessarily the progressive distance of the strip. Also, if I wanted to mirror this, I could to create right hand, left hand for a 2 out in that sort of situation. Let's now work with this particular part, and we want to establish if we're going to work with the die side or the punch side. My preference is the die side, and as we take the inner die side walls, it also measures the thickness, the gauge thickness of the material that is now stored within our setup, where we can also select the material we're going to work with. Within the library here, you see there's an extensive array of different materials. We can easily add more materials. It's just a matter of knowing what the specific properties are. And we can set the overall progressive distance between when we start laying out the strip. It's going to keep track of the overall strip width and length as we build it. Now, seeing that diagram, we're setting the distance that the punch will travel through the steel on shaping it and cutting it. And then we're setting up the clearance now for each of those components that you see on that diagram. Some of these are going to be a simple slug drop like going through a shoe. Others we're going to do a shear, so we'll put in the 10-12% you would expect. Others like the die backing plate, we're not going to have a hole. The punch holder plate, that's going to just basically be the retainer, so we'll put in what our slip fit condition is. Now we're selecting the type of die steel we want. Typically we see straight land, 1/4 inch with a few degrees of relief. So that's our preference. That's the way we want to design the die. Let's save that in the setup. Now that information is our go-to information throughout this project. Let's start with our first forming shape. Typically you might see this particular outer flange hit in a couple of different stations. Instead of taking the bend all at once, we might try to break it into a couple, maybe set one at 45 degrees, and then take it to final form. So we're going to create what's called a binder, or a face that's going to come off at an angle here at 45 degrees. If you're not happy with some of the surface conditions I see, you have a nice smoothing tool, or a patch tool we like to call it, that interrogates the part and says, well, we can do a little better job here. Let's smooth across those areas to get that binder that we want. It's got a good look to it as far as my angle, but I also want to extend the length out. I also want to make it a bit bigger So I have plenty of distance to catch the flange. There you can see it's extended out off the end, so if there's any shape to that, it's got a face to land on. That's what we're calling a binder faces. And you're going to see the flange will be bound to it as we execute this function called blank on binder. That's what we're developing too. That's the flange we're developing now, shown in red. We'll go ahead and let that calculate. Some of the things we can look at as we do this, though, include other forming conditions. Maybe I've got a pressure pad I want to incorporate. I may have a part that's using draw beads on a binder. That information can be included because it's going to affect the way that part gets formed. Now you see it developed to our 45 degrees. That's looking good. That would be the intermediate shape before we take it to final form. Is it formable? We'll quickly take it through our analysis tools to look at any area where we maybe develop some strain. Is there a wrinkle condition? Is there possibly a tear condition? Also, we can set this up so that we can look at some spring back. I'm picking a few areas. I'm saying hold on to that and let's see what possible areas of spring back may develop. It's based upon just that hit, just that development to 45 degrees. And there you saw in red an area that may show some spring back on the edge. We can take that information much further and actually doing the forming tool as well and adapting it to compensate for the spring back as well. Well, with that, now let's take this all the way to its form before we would have hit that at 45 degrees. We want to develop it to the top faces of the part, like you see here. So we'll select that as our forming shape. Again, use the same material properties as before, and tell the system to blank out to that shape or those series of surfaces, like you see here. So yes, we can blank to flat, but it's good to know we can blank to anything we can model. We can blank to anything that faces off of the part itself. And again, you can see how station to station now, we can go down the line and look at formability and see if we're doing something that perhaps is creating a difficulties for us. All right, with that, let's go a little further here in doing our forming. Let's look at the end now, where we've got those straight linear bends. That's a simple 90-degree bend, so we'll use our unfold function for that. All right. Basically, we pick the flat face we're developing too, pick the radius we're developing, and then our choice again, do we want to set that at an angle as we play with the radius? Do we want to move it? Do we want to make it bigger? Maybe we'll hit that at 45 degrees too with a bigger radius, and then come back and final form it. That way we can push on that radius and get rid of some spring back. In this case, we'll take it straight out to flat, and there you see it very quickly develop that. And with that, we'll go ahead with our next forming station. As you can see, we're kind of just like working in what we call like a notebook. We get an idea, we'll take it in that direction and take a look at it. Is it what we want? Yes. If so, then we'll proceed. If not, go back, go off in a different direction. So there's no set rules on which way you go about doing it. Just whatever makes sense as far as the process that you developed. Looking at this folded tab, let's develop that out to flat, and as we do so, let's capture where that rolled edge is. We want to put that in its position as if it were formed before this bend occurred. So we'll calculate it, and there you see as that is laid flat, the rolled edge where that pierce is now in the position planar to where it would have been before the fold. So a very nice and handy piece of functionality found in local blank. We use local blank again, and this time let's take the rest of that formed area to flat. So again, we create another forming station so that we have that information that we can put in a die strip later. Simply selecting where the flat is, using save material properties, let it do the calculating for us. Gone are the days of having to cut sections and take measurements and all that difficult stuff, tedious stuff. See, another form we need to take, if we want to get the shape of that punch that would go into the strip before the folding or the rolled edge occurs. So basically we'll lay that out flat now. Pretty simple, straightforward function. Again, just go to local blank, we'll pick that rolled up edge, and let it calculate. Now we get an idea of what the preliminary punch would look like before trying to punch that rolled up edge. So now it's laid out to flat. With that, we need to get the perimeter, so we'll calculate that using blank, and this is pretty straightforward. It's basically just gathering the outer edge so that we have the shape that we need of the blank for nesting, like you see here. It's a very handy function. It takes everything we have on the part and lays it out to a flat. So what we could have done is back here at the very beginning, maybe for quoting purposes, we wanted to get an idea of what the blank would have looked like. Simply go back to where we began. We'll calculate the blank at this point and let it establish the 2D perimeter. Maybe I need to know the overall perimeter for knowing my laser time if I'm going to cut it on the laser. An idea of what my footprint looks like, for a blanking die. And it's always interesting to compare the result of a one hit, which is what we just did, which would be like putting my foot on it, pushing it out uniformly, to this progressive blank that we did here at the end of our progressions. You can compare the two by overlaying it. You can see there's a little shift in distance, but pretty much the shape, the size is consistent. So for doing this for quoting purposes, you have no problem knowing that the quote is fairly accurate.